Right, good morning. Welcome to session 8G, which is the ABCs of dashboarding your mainframe statistics using Grafana. We've got a couple of guest speakers today from Broadcom, Tuan Elise and Rose Sakach. Just a bit of meeting etiquette before we start. The meeting is being recorded, just for your information, and throughout the meeting, you'll all remain on mute. But if you've got any questions, please post them in the chat, and I can unmute you if needs be, and we can step in and ask a question at that point there. Otherwise, I'll hand over to Tuan to kick off the presentation. Thank you.
Hey, good morning. Thank you very much, and thanks for having us. Let me start by sharing my screen, and you should see my slide deck now. Is that correct?
We do.
Yep, we can see it
Excellent.
fine. Yep.
Excellent. So, yes, welcome to the session. I think this is a topic that's very near and dear to my heart, because I've always been looking for ways to optimize the way I work, and this falls right into place as far as I'm concerned. I'll be co-presenting this with Rose Sekach, and I'm really proud that she's here. It's what, 3, 4 in the morning. So, hats off to Rose. Thank you very much for doing this. It's much appreciated.
Thanks for asking me. It's great to be here.
Yes. So here's the agenda for today. A little bit of who's who, so you understand what my role is, and what Rose's role is, and why we do this. Talk a little bit about why we do dashboarding. We'll go into an overview of all those building blocks that we throw together in order to build this solution. And don't worry, it's all open source. I'll speak a little bit about 2 different architectures to get data ingested in a place where you can work with it graphically. And then finally, how things are pieced together, the ABCs. Let me start with my personal introduction. My name is Tuan Michielse. I was born in the Netherlands. I've been raised in the Netherlands as well. I've done pretty much everything there is to do when it comes to databases. I've been a DB2 and IMS programmer. I've been a DBA. I've been a system engineer. I've been an architect. I even was lucky enough to work for the DB2 lab for a number of years as a lab advocate. And just before joining Broadcom, where I live now in Madrid, Spain, I used to be the mainframe architect at Swiss Re, a Swiss Re insurance company, and I was leading capacity and performance management team, and that is relevant to the topic today. And I was also leading a team of DB2 consultants, internal consultants. My passions are everything that has to do with data and mainframe modernization. And when I speak about mainframe modernization, I'm not talking about modernizing the mainframe. That animal is modern enough. What I'm talking about is modernizing the way that we interact with the mainframe. I'm talking about other ways to work with that beautiful beast than 3270 or purely 3270. And this session will address one of the aspects of that. If I'm not working, I like to do paragliding just to get stuff off my mind, and I like making a lot of noise, and therefore I play drums in the rock band in Spain called Ciencia Urbana. If you happen to like rock, check out our CDs on Spotify. And with that, let me hand over to Rose.
Okay, thanks, Tuan. Hi, everybody. Good morning. My name is Rose Sekach. I work for Broadcom. I'm an offering manager. But more importantly, I have a lot of roles in the open mainframe project Zoe community. I lead the onboarding squad. We work towards onboarding vendors to the project, as well as any of you who are interested in possibly contributing to the product. A member of the technical steering committee. I currently lead the Zoe Advisory Council, and I'm a member of the security group. I share all of this with you because this has been an amazing journey in open source and mainframe. I would love it if you participated in the community, if you had an opportunity. And in the event that you need anything at all or are interested in anything related to Zoe, certainly feel free to reach out to me. I believe our contact information is at the back of this presentation. Before Zoe, I was a product manager, mostly focused on mainframe software change management and DevOps. And then before Broadcom, I spent a lot of time out working mostly in the financial industry. As I started my career as an application developer, systems programmer, became a consultant specializing in software change control endeavor and RACF. My passions, believe it or not, is actually what I do. I work with amazingly talented, gifted, and self-motivated people in the open community. And when I'm not working, I'm usually working out with my husband. And if I'm not working out with my husband, I'm spending time with my sweet canine companion Triumph, who recently earned another trick dog title that we're very proud of. So that's who we are. I think collectively we have, I don't know, maybe close to 80 years of experience in mainframe. So, so today we're going to talk about dashboarding, and why are we talking about dashboarding? So if you go to the next slide, it's really because you are and your organizations are leveraging them as a tool to assist in some of the challenges that we're all faced with in the mainframe space. And many of the reasons for leveraging dashboards are listed here, but in general, organizations are finding a lot of value in bringing mainframe data forward in a graphical form. And prior to just recently, and we'll talk about why in a moment, it wasn't so easy to interconnect the mainframe with the rest of the data center. But because of what's happening in the transition that we're faced with a lot of folks who are very highly skilled in the mainframe retiring and new folks coming into the space, there are challenges that we can directly impact by giving you all some information and giving you the ability to leverage open source and take advantage of dashboards. So we'll focus on the three advantages highlighted here. We see them as, first one is empower end users. In our world, we call this shift left. And that really means to move the tasks away from the SMEs that are responsible for a lot of work, and particularly some of the manual work. The next one, what we mean by improve efficiency is really to help less skilled people achieve more in less time. And I think Tuan's example will show you how you might be able to do that. And then from a visibility perspective, if you're able to know something's going wrong sooner and react faster, then you have the ability to improve those MTTX scenarios. And by that, I mean, mean time to discover, mean time to recover, and mean time to repair.
Yes, and thank you, Rose. I think what Rose said in the previous slide is so important that I repeat it in my own words a little bit. I mean, nowadays, what we find is that organizations are being pushed to deliver business function faster and faster. For years, we've been looking at availability, but also ways to make, to deliver function much faster, and that extends to what Rose was talking about, problem resolution time and turnaround time, but most of all, quick detection. And the reason for that is that we no longer can tolerate outages or longer outages, and every problem that you don't discover will have some impact on your business. So if you can detect when things are going wrong, you might be able to prevent a few things, so avoid problems. And of course, that's the best problem to have, the one that you avoided. But as Rose said, there's also this need to shift left. Especially in the mainframe industry, we find it sometimes harder to to find and retain the skills, the deep skills that that we traditionally have in the mainframe space. So if you think about is Sysprog. Sysprog typically has very, very deep knowledge about one or more products, but it takes a while to get that experience, to get that knowledge, to make it useful. And if those highly skilled individuals, if they are, bogged down by, let's say, activities that don't really require their deep skills, then that's a waste of efficiency. So what we're trying to do is make sure that we enable um, other individuals in the organization to do at least part of the work, right? And that's what we call shift left. And then the other thing is we need context. So if we take, in this case, monitoring seriously, then it's no longer enough to just have a whole bunch of numbers, but we have to put those numbers in context. And the context are twofold. First of all, there's the time context. And what I mean with that is that if you bring time into a series of numbers, then you can see how those numbers, those metrics, evolve. And you may see that, let's say, the metric that you're interested in is an indication of capacity. If you start reaching the max capacity, you know that problems are around the corner, right? So that's bringing time, the time context into play, but also the persona. And so if we start shifting left activities, then maybe the way that we look at data should be slightly different from, let's say, when an SME, a system programmer, or a DBA looks at the same data. Right, so being able to adjust what we see to the persona will also help the productivity of that persona, in that sense. So if you look at this screen over here, right, that's a very traditional performance monitor screen. In this case, it's SysView for DB2, happens to be a product that I like, but it's just a bunch of numbers and it misses the time context, for instance. There will be a timestamp, but you don't see how things evolve over time. However, it does present a lot of information, a lot of data from that particular snapshot in one go. So that has value certainly for someone who wants to see, correlations between numbers. But for the average operator, it's much easier to see things in a graphical representation. And that's why what we want to do is transform those 30 to 70 screens, or the data that's collected in 30 to 70 screens, and a whole bunch of them into a dashboard, like the one that you see over here. And that will help both all of the above, right? The need for speed, the ability to shift left certain capabilities or certain activities, and the context.
All right.
Rose.
So how are customers making all of this happen, and why is it happening now? And really, it starts with data and the availability of data. And APIs are really at the heart of making the mainframe data that you're looking for more available than ever through the solutions that leverage them. And though they're not necessarily open per se, because they may be related to specific vendor products and services. They are a relevant building block to and the introduction of them really has changed the game when it comes to making mainframe data available to all of the open source tooling that can be used throughout the IT industry and is used by other platforms for this purpose as well as others. So APIs really are at the heart of where you're going to get that data. Now, when it comes to securing those APIs and managing those APIs, the true open source piece of information that the first one, I guess, that we'll talk about is Open Mainframe Project Zoe's API mediation layer, which is the piece of software that sits on Z. It's part of Zoe that manages and secures the APIs. As we say here, it's an open source component. It does the job of centralizing all of the APIs associated with any of the products and services that you want to access on the mainframe. It serves as the heart and soul, the security hub, if you will, enabling all of the back-end services, or I should say, enabling anything that you want to access to be secured in a manner that you expect on the mainframe. So the API ML leverages all of the security protocols that are already in place on the mainframe, the enterprise, the ESMs and SAF that exist there. Although we're not going to say that the mediation layer is required for the purposes of yourself getting started with building your dashboard, as you continue to realize that more and more services may be advantageous in the form of an API, we do recommend that you leverage the mediation layer as you move towards a production rollout for any of these tips and tricks that we give you with respect to dashboarding or anything else when it comes to services. So it's open source, part of Zoe, helps you to manage and secure your APIs, offers you the ability to limit your ports to a single point of entry versus having to manage a tangled web of services, if you will, and maintain them as you go. So that's the first piece of open source. Now, one of the features associated with the mediation layer is that we call it extensible, and essentially what that means is that it offers the ability for any vendor or any customer, if you so desire, to build your API, and provided that it satisfies a certain set of criteria as defined by the Zoe API Mediation Layer Conformance Program, then you are essentially guaranteeing that your API will have and be able to take advantage of everything that the API mediation layer offers, including security protocols like multi-factor authentication, single sign-on, 509 certificates, and ensure that your API is secured as well as any API that's permitted to be onboarded to the mediation layer. So the bottom line here is that if you want to ensure that the APIs that you use have the correct, are constructed in the correct manner, then the best place for you to confirm that is to go to the marketplace of available mainframe vendor services, which is the OMP Zoe conformance site or the conformance landscape. And we recommend that here at the bottom of the slide. So that's a link directly to the conformance landscape.
Right, and thanks, Rose. That's really one of the most central pieces of equipment going forward, I think. Now, apart from the API ML, I'm going to introduce very quickly two other open source components. The first one is Prometheus. Prometheus is a piece of software. It's open source, even though you can get a support license if you want, but essentially it's free to download and install. It implements like a time series database. So that's the part where all the metrics that we're going to be using in our dashboarding are stored in a very, very efficient manner. It takes very, very little storage to store, months and months of data. Apart from a time series database, it also has an alerting engine, so you can use the data that you have in there to trigger activities. And the beauty of it is it runs everywhere. It runs on Linux, it runs on Windows, it runs on Mac. You can have a Docker image that implements it. So it's very versatile, runs everywhere, whatever your preferred platform is. And in essence, what it does, it will use an HTTP pool model to collect data, and that's important, right? Rose is talking about RESTful APIs. RESTful APIs are invoked by using the HTTP or HTTPS protocol, and that's exactly what Prometheus does. So provided you have RESTful APIs somewhere in your environment that will provide metrics, you can use them and ingest them in Prometheus. Apart from the fact that it pulls data and stores it in the data, it also provides ways to get it out. So it has something called PromQL. It's Prometheus query language, and it's more or less SQL-like. So if you understand SQL, if you understand the function of predicates to filter data, then it's very easy to learn. And by the way, other components will actually help you construct PromQL, so you don't have to write it from scratch. And the beauty of it is it integrates with a whole bunch of open source tools. And one of them I'm going to highlight here, that's Grafana. So Prometheus will be, capturing the data and storing the data. And Grafana is the open source component that I use to visualize, to turn, all those numbers into understandable graphs. Again, just like Prometheus, it runs on pretty much all the platforms you'd like. So it's Linux, Windows, Mac, and Docker. And similarly to Prometheus, you can get a support license if your organization wants it, but you can just download it. Once you've done it once or twice, it'll take you no more than 5 minutes to get it up and running, including the download on your platform of choice. And what it does, it out of the box, it provides tremendous amounts of visualizations. And visualizations for me is the key to productivity. I mean, in a proper visualization, you see in a glance, in a microsecond, you see if something is wrong and requires more attention, or whether everything's hunky-dory, you can just move on with whatever activity you're performing. Right? So it's extremely important as far as I'm concerned for analytics and monitoring. It also provides out of the box capabilities to even, make also the interaction between individuals in the organization more efficient. Grafana itself supports a variety of data sources. In the example that we're going to take you through we're only talking about Prometheus, right? So with that combination of Prometheus and Grafana, you'll have extremely powerful capabilities to create, explore, and share dashboards. So a little bit about the possible architectures in which you can use this. And before I delve into that, I'm going to introduce two terms that I just dreamed up to make it easy to understand, and that is what I call compliant Prometheus format and non-compliant Prometheus format, and that has to do in the way with the way that data is being returned from the RESTful API. I have examples of both types of data returned that we use in Broadcom software. So on the left-hand side, you see something that I call compliant Prometheus format. It's just the way that the data is structured. You can see there's a if I look at the first line, it says year, and then in curly brackets, SSID. So the year, that's the metric that we're talking about. Then the stuff within the curly brackets are sort of are labels that we can attach to that particular metric. And then finally, you get the in red, you'll see the value. And Prometheus will just consume all that data and store it in its own database. That's compliant. Now, that is not the format in which most RESTful APIs return their data. Most RESTful APIs, they would use something like JSON. You see that on the right-hand side. It's also labeled data, but it's not. It's clearly different from what you see on the left-hand side. Just remember those terms. So JSON, non-compliant, Prometheus format, that's funny, textual format. And that has implications. If I have a compliant data provider, then all I have to do is, make the endpoint, the address of the endpoint available to Prometheus, give it some other metadata like how often do you want to pull the data, are there parameters, are there input parameters that I need to pass to the RESTful API, all that good stuff. authentication, and off you go. And then Prometheus will do the rest automatically. And Prometheus can, of course, call the API directly. However, as mentioned, we strongly recommend that you invoke your APIs through the API mediation layer for all the important stuff. So once that path is established, once Prometheus can actually reach out to the API through the API mediation layer and say, "Give me the data," it will store it in the time series database. I think I mentioned it. It's a very efficient way to store large amounts of data points. And from that point onward, I can use Grafana to interrogate Prometheus over PromQL to put it in Grafana dashboards. By the way, PromQL in itself is also, passed on to Prometheus through a RESTful API. So if you have other applications, maybe you write your own, I don't know, operations tool, then you can also include Prometheus data very easily in a graphical representation. So Grafana just makes it easier and has a lot of out-of-the-box visualizations, but that's surely not the only way that you can consume the data once it's in Prometheus. Now, if I do not have a Prometheus compliant format, so if I have JSON or anything else for that matter, then the architecture is slightly more complex, but not very. So what happens then is I need something that's called a node exporter. So I have a Python script here in the middle, and that functions as a proxy. So Prometheus just accesses the Python script over RESTful API. This Python is just listening to an HTTP port, and whenever Prometheus asks the Python script for data, thinking it's the RESTful API, then the Python script will, under the covers, invoke the RESTful API through the API mediation layer. But then it has control. So rather than feeding the data directly back, the Python script will actually transform that non-compliant data, that JSON data, it will parse it and push it through the Prometheus API into the database, right? And that may sound complex. However, if you go along this road and you need a node exporter, please send an email to myself or Rose, and we'll get you a working sample. Now, excuse me. So that works if I have a non-compliant data provider sitting behind an API, but essentially that could be anything, right? So once I'm in the Python script, every piece of data that's accessible from that Python script, I don't care where it comes from, that can also be used as a data source to feed Prometheus. From that point onwards, it's the same story. Prometheus stores the data in the data store, and we use Grafana to create the nice visualization. Any questions so far?
None in the chat, no.
Thank you. So now we come to the, I guess, the most exciting part, the ABCs. What do you need to get started with this, apart from the open source software? Right. First of all, you need to install it. I'm not going to go into all the details. Just going to highlight a few important things for the installation. And the reason I can do that is because the whole installation procedure is so well documented. So if you use any of the links that I have in the slide here, you can find all that you need to perform the installation. Really, it's a push of the button, right? However, you need to do it for both Prometheus and Grafana. It's all open source, and open source also means that Google is your friend. If you have a question, just Google it, and for sure the answer's already there. If you do nothing else, if you don't do any special port assignments, Prometheus will be sitting at port 1990. And that's important because Prometheus also provides a web interface that you can use to interrogate the status, stuff like that. And Grafana by default sits at port 3000. So if you have built your dashboard, you want to have access to Grafana, that'll be either your local host or whatever the host name is, port 3000 you get there. And of course, if that doesn't sit well, you can always change. Now, once you have that software up and running, you can verify really quickly. On the left-hand side is, once you have your host set up and the Grafana on that port, in this case 3000, you just go to that endpoint, port 3000, and that will drop you into the default login panel. So if you have done no other configuration, that is what you will get. And there is a default user ID password, admin, that you can use to verify your installation. That's all there is. Now, once you start working with it, you probably want to, tweak Grafana to your own liking. Maybe you want to define user IDs or a way to invite user IDs to use it. All that good stuff, email preferences, all that good stuff, you can configure in Grafana.ini. Very well documented, very easy to use. The second part of Prometheus, I said Prometheus also has a web interface. By default, it lives on port 9090. And if you just want to verify that Prometheus is up and running, you go to that port and you see something like this. And then you know that at least your installation is done. Perhaps not the configuration, but at least the installation. Then you need to configure. And the most important part, of course, is to let Prometheus know what kind of data you want to ingest. So what you will have to do is define so-called scrapes. A scrape is one invocation of the RESTful API that provides the data. And you do that in a YAML file. If you're not familiar with YAML, it's very easy to read. It is sensitive to indentation, so you have to make sure that everything indents to the proper place. But it's really easy to read and to write. And there's all kinds of, if you use Visual Studio Code, there's all kinds of, syntax checkers that'll alert you to things not being, exactly right when you have a YAML file. Now, what you do is you define so-called scrape configs. A scrape config identifies a target. Right? So if you look at line 8, that's where my scrape config start. I have a job name called DT31. DT31 is one of our DB2 subsystems in the demo environment. You tell it how it should be reached. In this case, it goes over HTTPS. That should be the default. And what you see over here is I use basic authentication. That is probably the first thing that you want to get rid of, right? So you probably want to use certificates. However, this is just the easiest way to express. So I have a user ID and a password, the worst when it comes to security, right? But that defines, how that job is going to be accessed. But you also need to tell it where. So you have to have the exact metric, the REST API endpoint, right? The metrics path that you see over here. In this case, I invoke a function called Prometheus generic, which is one of our endpoints in our sysview for DB2 products. And that takes a bunch of parameters. The parameters are below from line 15 to line 18. And those are just parameters that the RESTful API expects. So the function, let's say a cluster of data, etc., etc. Once you've done that, you also need to tell it where to find it. So you have to define the target, the host on which the RESTful API provider runs. Hopefully that will be your API ML, and you identify that by your host name and your port. And that's pretty much it, right? At the top, between line 2 and 6, you'll see some general parameters, and that is, for instance, the scrape interval. So how frequently you want to get the data. 1 minute is an interval that I really like, but you can tune it down or up depending on your preferences. And then there's something like a timeout. If you would have a very, very inefficient RESTful API, or it's not reachable, at some point you want it to time out and not hold up everything else. So that's what you would do over here. Okay, so that's the main configuration for Prometheus. Once you have configured at least one scrape config, at least one job, you can use that web interface in Prometheus to see how it's doing, right? So once you've changed it, you either have to restart or use a curl request to reload that new configuration, and immediately you'll be able to see something like this. Now the subsystem names don't match, but it's not too much different. What you have is an overview of all the endpoints that you've provided, all the jobs that you defined, and you can see whether it's well in an upstate according to Prometheus. In other words, whether the last scrape actually returned data, or and you can see how long the scrape took, and by that you can very quickly monitor that Prometheus is doing the job it's supposed to do, and that is getting the data out of the REST endpoints. That could be a whole bunch of them, and put them in the Prometheus database. So then the second point, and that is, we have to get Grafana up and running. So the first thing to do in Grafana, once that interface is done, is to make sure that it's made aware of the Prometheus instance. Now you can have Grafana allows you to define a whole bunch of different data sources. Maybe you'll have multiple Prometheus databases that work for some part of your organization. That is very easy to integrate. So you just add data sources, and once you go into the add data source dialog, it will it will ask you for the type. In this case, it's a Prometheus data source that I want to add. You have to fill in some details. Not too much. You have to give it a name so you can identify the instance in your Grafana queries, in your PromQL queries. And you have to tell it where it lives. Same port as that you use for the web interface. The default is 1990, but of course you can call it anything you like. And once you've done that, that's pretty much it. You save the connection and you're done. You can test it, and now you're ready to actually start building dashboards. Now, I have these slides in here, but I think it might be better if I try to do a demo. How does that sound?
If you want to risk it, Twan, go for it.
I like living on the edge.
Go for it.
So I go to my web browser, like here, and do you see my web browser?
Yes, we
Yep.
do.
Yes. Yep.
Okay. Now this already dropped me into, well, let's call it the dashboard for now. And why I say that explicitly will become clear at the end of this. But what you see is a whole bunch of visualizations, right? There's a whole bunch of graphs. I can scroll through those graphs. I can make them bigger. I can do all kinds of stuff with it. Uh, and collecting a bunch of visualizations that have a certain relationship with each other, that will help you build your dashboards. Now what you see here over here, the breadcrumbs, you'll see that I have I have a collection of dashboards that I call DevOps demo, and the dashboard that I'm looking at is something called the group wide view. Now this is for a DB2 data sharing group. If you're not familiar with a DB2 with DB2, a data sharing group is just a collection of subsystems that share the same catalog running within the boundary of the sysplex. So that allows a process to access data using the local DB2, but that same data could be accessed from a completely different LPAR. That's what DB2 data sharing is. Now that means that I have different DB2 instances, and what I have here is a collection of metrics that describe the whole group, the whole data sharing group. You can have a look. I don't want to go into the details too much. I just want to show you what you can do with dashboards, right? So one of the things you can do with dashboards is you can automatically link to other dashboards. You see here I have a group identified as DGP in a variable, and I have some other links, really. That's what they are, dashboard names. So from the group wide view, using the group that I've selected, I can go to the group by member view. And since I changed it a little bit, it wants me to save it or not. Now, if I go into the group by member view, I will have similar statistics or whatever I want. However, I break it down by DB2 instance. So if you look on the right-hand side, the active thread counts, you'll see the names DT11, DT31, DT32. Those are individual DB2 subsystems belonging to the same data sharing group. The data is pretty much the same. It's just represented in a different way that makes sense for this particular view. And that's what I mean with context, bringing data into context. Now, to give you an example, the group-wide view gives me, overview of the state of the entire data sharing group. However, if you think about such a constellation, probably what you want to do is make sure that the workload is balanced nicely across your different participants, your different members. And by taking the same data but organizing in a different way, you can see if you have achieved that goal. So you can look at that particular type of context. But there's a hell of a lot more that you can do. For instance, and I need to get this out of the way. Yes. For instance, what you see over here is the interval that you're looking at. I told you, one of the things that I would like to have is the context of time. And here I can change the context of time really, really quickly. So I can go from the last hour, I can go to the last 6 hours. And you can see, all the visualizations are automatically adjusted to that new time range for all of the visualizations I have in this particular collection, this particular dashboard. But if I would go to other dashboards, you'll see it's exactly the same. So that's one thing. Now, if you so now you are, for instance, able to see patterns more clearly, right? If I go back to, let's say, I don't know, the last 5 minutes, then I have data, but it doesn't necessarily allow me to look at bad patterns. As soon as I take a larger scope, let's say the last 24 hours, then I can start seeing trends and patterns in my graphs, right? So that's another context that I build in. Now, when we introduced the session, we talked about shifting left, right? Now, this whole collection of visualization is certainly important for, let's say, the SME that wants to see a lot of things in context. But if you think about, let's say, your first line of defense, your operations staff that sits maybe, in a place far, far away, you want to be able to instruct and say, I want you to look for things that are out of whack, that are out of the norm. Now, if you look at this particular visualization on the left, accounting total DB2 CPU time. Remember, this is a demo system, so don't take it with a pinch of salt, right? But it's very easy to see that I have hardly anything for a large number of hours. Then all of a sudden I have this peak. Now, that is something I can teach someone without understanding what that particular counter means, what that technically represents. I can tell people, say, just keep an eye on this, and if you see it's out of whack, give me a warning. So this is clearly out of whack. And the particular individual can zoom in on the interval just by selecting the range, and you can see it nicely adjusts across everything. But let's assume that this guy now has identified something that needs to be transferred to the SME. So you wanna invoke the SME with little impact. So here's a capability that comes out of the box that I really, really like, and that's the capability to share dashboards. So if I click on the share icon over here, this dialog pops up and it gives me the capability to copy the URL. Now that URL describes exactly what that individual is seeing. So it has the parameterization, that's the data sharing group. It has the time range in a variable. So you see the people who would receive that URL and follow it will jump exactly to the point and see exactly what that operator was seeing. Now, why is that important? Now, I don't expect your operators to communicate directly with the SMEs, right? They don't pick up the phone. What they would typically do is open either a snow ticket, a snow incident, or a Jira incident, and they say, okay, I need help. I need someone to investigate this. Well, in the old days, you would have to maybe put a lot of words around it or copy and paste a lot of these things to express what you mean. Now, all you do is copy, attach the link to the Jira ticket and send it off, and that's it. And that's another example of productivity gain that you can achieve using these dashboards. And there's a hell of a lot more. Now, so what you see again is a whole bunch of dashboards that we created in Broadcom and that we ship to our customers. Now, you may or may not be able to consume this as is. if you would happen to be SysView for DB2 customer, plus you have the RESTful API installed, then you just go into our install material, you'll find the JSON file that describes this, you import it, within half a second, you have this dashboard up and running, provided the data is there, of course. And it's not just this one dashboard, there's 4 dashboards on the DB2 general side, including buffer pool stuff, and there's a new series of dashboards, also 4 of them that are focused on distributed workload. Now, distributed workload is interesting because I think more and more companies will have a mixture of cloud originating workload um, combined with processing on the mainframe, right? And that means that as far as DB2 is concerned, and I'm a DB2 guy, you get into the notion of DDF, everything that comes in over distributed protocol. But there's more, and there's more capabilities to Grafana. One of the things you can do is you can, Grafana as a visualization method, it doesn't really care what kind of data it is, right? So in this case, I have IDMS systems. IDMS is one of Broadcom's database, and they also provide, endpoints with statistics. So you can put that in the mix as well. You can also have Linux machines providing data, right? So harder the matter is, once you have, the dashboard capability, you can actually represent your entire infrastructure, if you will, because nowadays, I would expect that, most operation staff will not only look at stuff on the mainframe, but also, get the context of the driving platforms like Linux, like other servers that connect over DDF. So that's another capability that you get pretty much out of the box with Grafana. And that's only half the cool stuff you can do. Now let me show you by giving you an example how easy it is to create a new visualization. So if you want to create a new visualization into your dashboard just because you like it, you just click on the add drop down here and select visualization. Now that will open a panel over here where you can select the type of visualization. Most of what you've seen is time series, pure time series. So it has a data point for each interval in the range. But there's a whole bunch of other out of the box type of representation that you can use. You can have pie charts, have bar gauges. It depends on what fits, what fits the use case best. And so once you've chosen the visualization type, then you go into the part over here where you would select the metric. The metric is, the values that you want to see. And since I'm already connected to Prometheus over here, I have my data source Prometheus. I can just go in and start typing something that I think is the name. Let me go with buffer pool get pages. That's one of the metrics, and it will populate the drop down with everything that could match. Right, so I just select a metric. I can give it a label. I can give it labels, and I can add operations. So in this case, a buff. If you look at a DB2 subsystem, you'll have multiple buffer pools, each with their own name. So I want to, separate those statistics out. So what I'll do is I'll aggregate, and I will get the sum of the get pages, and I will do that by a label called index. Now, if you would go back to the slide that shows the conformant and non-conformant, you will find an example of index, but index means I have a repeating group in the data, and the repeating group is identified by the buffer pool ID. And this is all I have to do. So that was 2 clicks, wasn't it? And I can just see if that okay. I run my queries and I have it. And automatically I have the data. I have also the individual labels, in this case the buffer pool. That's all automatic. And now what I can do is you can just beautify it, tweak it to whatever I like. So for instance, I don't like to have the legend at the bottom. I like to have it on the right hand side like this, right? Maybe there's other stuff that you want to do. Maybe you don't want to have individual data points for the series, but you want to stack them. That's all the good stuff that you can do just by clicking and seeing if you like it. So there's a lot of capabilities. You can nicely color it, this and the other. Very easy to create your visualizations. Much easier than trying to get the data in an Excel spreadsheet, then creating. You know what I'm talking about, right? So very easy. You can save it, and automatically it's part of your new dashboard. I'm not going to save this. I'm just going to discard it and remove the panel I just added. Um, and that's pretty much how you would create a dashboard. So let me go back to the presentation. Um, oops, that was one too quick. For some reason I kind of just a second. You should see the presentation again. Is that correct?
We do. Yes, we
Yes,
do.
we do. Yes,
Okay.
you were living dangerously.
Good recovery.
I know,
Recovery there. You did.
but we did it. So
We did it.
you in the handout material you'll have pretty much everything I told you, all the clicks to make. It's only a few clicks and you'll have your dashboard up and running, provided you have the data, of course. So with that, I think it's time for a summary that roles will drive.
Yeah, thanks, Tuan. So we Tuan spent a lot of time here going over the how to make this real, right? And how to connect to the technologies, if you will, and leverage the open source. But the question for you really is, where should you begin, and what should you start to consider? What should you focus on? And the best advice we can give you here, and this is what we do with a lot of our clients, is we ask them, well, consider your pain points. Consider, are you in the process of having to do some knowledge transfer and onboard someone who's new to database administration? Are you working on a small team and there's just too much work funneling in to your team and yourself? I know for myself personally, we went through a period when I was an administrator where we actually logged all of the work that came in for a period of a month. And man, did that open our eyes as to where we were spending all of our time. So that's something you could consider. And then also, consider whether or not you're reacting to outages versus trying to proactively prevent them. And that would open up, another opportunity. So the bottom line here is just, sort of take the time to reflect and consider where you're spending too much time. And then, we've got our ABCs in the back here. Our advice would be just start very simple, start in your sandbox, and then stay with it. We can almost guarantee you that you'll find something that will work to your advantage. And then I think we have, a general summary here. We're a big fan of leveraging all of these capabilities that are now available to you and to mainframers. The introduction of RESTful APIs really broke open the floodgates, if you will. It gives us the ability to obtain data from the mainframe like we've never been able to do before, and truly making mainframe an integrated part of your IT and your data center. There's lots of open source tools out there. We're recommending you start with the tools that Tuan suggested, Prometheus and Grafana. I'm sure there are others out there that you can play with as well. As we mentioned, the architecture is flexible. And it's open source. The installation and configuration is within your control. So all good reasons to consider and try it out for yourselves. And then I think on the next slide, Tuan, we have actual these are really, this is the checklist where you can print it out, walk away with it, and reference back the material that we have in this presentation. It's really about install, configure, and use. And maybe you might look at this and say, okay, it's a little oversimplified, but not really. One item that we do want to point out, as I mentioned earlier, as you move forward with anything related to these leveraging these APIs and considering more and more APIs, we do recommend the API mediation layer with production rollout for all of the reasons we stated earlier. Do not necessarily need this for your experimentation phase, which we obviously would recommend that you do first. And then anything else you want to add to this one?
Yes, there's this one little checkbox that says, and it's bold, create true dashboards.
True. Yeah.
Now that may sound a bit funny because I just showed you all these wonderful collections. What I mean with that is the following. At the start of the presentation, it says, it's very important to be able to show data with the context of the persona. What I mean with that is the following. The SME, that DB2 specialist, SysProc or DBA, he will be very happy to see all those graphs and browse through them and scroll through them, just because he has the time to do so. However, picture another persona. Picture the persona that we want to shift left to. Picture the first line of defense, your ops room. Last time I was in the ops room, I must admit it's a few years ago, but last time I was in the ops room, I was overwhelmed with the number of screens. And of course, and you have a number of operators, and they look at different parts of that wall of screens. What's important, however, is that these guys, they don't really have too much time to spend on the dashboard. And that is analogous to, the most famous example of a dashboard, of a working dashboard. And that's the dashboard that you have in your car. The dashboard in your car is very simple, with reason. Right? The reason why it's so simple is because it's supposed to work while you're doing 120 miles on the highway. Well, maybe not exactly 120, but at least you're sort of testing the speed boundaries and maybe go over a little bit. Now, what that thing is supposed to do is to tell you if you're in danger of getting a ticket because you go over the speed limit, or maybe in danger because your car happens to be breaking down. If you would have to, look at that dashboard, look at that set of visualizations, scroll down, up, left, select time ranges, you're not going to survive very long, especially not at 120 miles an hour. So let me just give you another example of how you can use Prometheus and Grafana to build what I call true dashboards that have the persona in mind. So I'll go back to my screen here. I'll just open a different tab if I get this out of the way.
I'm conscious, Tom, we're almost at the top of the hour if you've got any questions, so just to mention that.
All right, thank you. This is the last thing I'm going to show. But what you see here is not a whole bunch of graphs. What you see here, and a DB2 person will recognize this, is a bunch of components in DB2, and it has these yellow, green, and red counters. Now, all of a sudden, this represents what happens in your dashboard, right? You have a red light if your engine is running hot, stuff like that. If everything is green or doesn't show up, I can ignore that completely. However, if something is yellow or red, that may be an area that has to draw my attention. So if you have that, within the blink of an eye, you can see if there's something you need to focus on. And if there is something you need to focus on, you just go and then you go into, the visualizations that provide you all the details. So that's what I meant with a true dashboard. And with that, let me go back to the presentation for the final slide. And that is, I want to leave you with these customer quotes. This is one of our customers that has been an early adopter of the dashboards, and he already saved it, and you can read the actual quote. It already saved his valuable time on a number of occasions. And then finally, questions.
Thank you very much, Tuan and Rose. I'm just going to allow participants to unmute, so I'm going to open the floor very quickly because I'm way over the top of the hour now. For any final comments or questions that people have, just unmute yourself and fire away. If not, many thanks for the presentation. It's very interesting. And just make sure any feedback. Have you got a QR code or something? It was session 8G, I think, wasn't it?
8G, yes.
8G, yes. If people can feedback, that would be appreciated.
Otherwise,
all right. Thank you.
Thank you very much.
Thank you very much.
Yes. Have a wonderful day and conference.
Thank you. Take care, everybody. Goodbye.
Take care.
The question about the recordings, the slides should be up on the website, but if you want the recording, it will be available in a couple of weeks or so after editing.
Thanks, Anna. Thank you.
Welcome. Okay, so if there's no more questions or no questions, we can you can unmute yourself. So
yeah, they can unmute themselves. Yeah, I think people are just
yeah.
leaving now. Yeah. I'm just so conscious of the top of the hour.
Okay.
All right. Thanks again, and
Excellent.
hope to see you in person sometime.
Yeah, definitely. Yes.
Yep. In November, hopefully.
It'll be nice. Yes.
Right.
Lovely. Okay. Thank you very much.
Thanks. Bye-bye.
Okay. Cheers. Yeah. Take care. Bye.